Hello, welcome back to my bench. I've been told by a couple of you out there, or some of you, that you want to see me do my my repairs, whether I consider them interesting or not. So, a lot of what I do is pretty basic stuff, and I guess after having done so many of these things that it just gets to be, here's another one of those. I mean, I've done a lot of 528Es, and trust me, you don't want to see every one of those up on the web here. That's for sure. I mean, so anyway, I'm going to start trying to do more videos of just the stuff that comes in that I get to fix, and if you're interested, that's neat. I'm glad. And we'll see how it goes here. So anyway, today on the bench we have an Orban Model 111B dual reverb. This is old school, man, I'm telling you. This actually has real, honest to goodness springs in it. See the springs? Yep. This is an electronic reverb. This is a spring reverb, which is really where you get the best sound. And today we're going to find out if it works and how it works, and see if it doesn't work, see if we can fix it. I just took the top off of it, to look inside and see if there's anything blowed up. I don't see anything blowed up, which is good. I do, however, see over here somebody has been in it and replaced a cap or two, or at least one there. But I really don't see anything else that looks messed with. So I guess what we'll do, the first thing we'll do is we'll just turn it on and see if we've got any voltages. That's always the first thing that you do. So let's give it a switch on here and see what happens. It's on the dim bulb tester for safety's sake and no fire sake. I've got it hooked up with the input coming off of the function generator, 1000 hertz, 2 volts peak there. Yeah, 2 volts peak. And going into the little the little scope, the Handtech scope. So we'll see what happens there. Let's bring it up. Let's bring up the scope. There's the scope there, and we're on. We can get rid of channel 2. We're on channel 1. We're down at 200 millivolts. There's 500 millivolts. Let's turn this thing on and see what we get. Ooh, we get what looks like a square wave. Yeah, that's not pretty. Okay, kill it. Let's check for voltages first. Always check for voltages first. Let's look at the manual and see what our power supply looks like. That would be down here. Right down in here. It's pretty simple. Comes in, goes through a fuse, a switch, transformer, full wave bridge rectifier, and a couple of ICs. Looks like plus and minus 15 volts. Yep. A couple more caps. Let's see, this is what, 470 at 40. 470 at 40. I think that's the one that's been changed over here. Got your 15 volts there, plus minus 15. Then it goes through 3 41 48 diodes for a voltage dropper. Some more filtering. And that's how they derive their 12 volts, is just drop it by 15 down by 6/10, 1.2, and so 3 to 18, 1.8 volts, and close enough, I guess. Well, that's one way of doing it. Anyhow, so let's take a look at our voltages first. Where can I get them up? Minus. I do not believe the case on this is minus. So I'm going to go to the negative end of C301. C301 is going to be this guy right up here. So, yeah, negative end is the one towards the back. So that would be right over here. Let's get the meter in the frame here. Go into the negative end of C301. And first thing we'll do is we'll measure the plus side of C301, which should give us about 22 volts, it says. So, hello. Oh, there it is. Got to actually get on the right thing. Yeah, 22.1 volts. Perfect. All right. So, where can I check the other voltages here? What are these guys? There's a couple of ICs in here. There's this, 107, 105, 109, I don't know, 107. Let's look at those. There's 107 right there. It's a TLO 72, it looks like. So that would be, there's the pin 8, 14.9, pin 4, minus 15. So our regulators are working too. What's it look like for noise? On the B plus, virtually nothing. B minus, .24 and dropping. So nothing. So that's fine. Okay, well, voltages are good. Now let's see if we could figure out where we're going here. We'll just use the scope. Turn on channel 2, turn off channel 1, move it up, and bring the scope back in. Alrighty, there's my scope. So, with the manual, I guess, let's, where is the output? There's the output attenuation's right there. I've got everything centered on the knobs up front here. So let's, what is this? 105? Yeah, 105A. This isn't the world's most beautiful. Yeah, 105A. So where would that be? That's 106, 102. I'm on the left side here, so let's see. 107, 103, 105. There's 105 right there. It's what is that? That would be over here. Okay. So what are we looking at? 105. There is, okay. I'm just working back from our output to the first thing that makes sense. So that would be pin 7 of 105. So pin 7 would be right there. Scope. And we got, wow, that's a lot of something. And voltage. Oh, okay, there we go. The voltage was doing it in. All right, so we've got our voltage. We got input there. That's 500 mils. So that's 1 amp, 1 volt almost. So that looks good. So where's it go from there? It goes down through this output attenuator over to IC 107, I believe that was one of these down here, wasn't it? Yeah, it's this one down here by the thing, so it's down here. So if we look at 107, which is right here, let's take a look at the output of 107 and see what that looks like. And that's on pin 1. And go up here, bring the scope back up. Yeah, we got output. Now this is post output attenuation, and that would be this knob. So, yep, there we go. That's varying. That looks good. All right, and then it comes out. It goes through the bass. Goes through the bass, the mid-range, the bandwidth, all those knobs in the front. And then it goes over to this EQ module. And I hope to goodness that's not bad, because that ain't, I don't know what the heck that is. Maybe that's that little thing down there. I could probably build one of those if I had to. Anyway, it also goes into 109, which is a TLO 72. So if we go down, whoops, 109, which one? 109 was that one right above it, wasn't it? Yeah, 109 is right there. So, go to the scope, says 109, and I want what? Pin what? We're good to this point anyway. 109, pin 1 and 7 between A and B, so they should be about the same. So, there's pin 1. Ugh. There's pin 1, and it varies with output gain. And here's pin 7, and it does the same. So going into that transformer, the transformer right there, we have it. And then left direct out in the back, so that would be good. All right, so then the other part of it going out is the left mixed output, which is what I've got hooked up to the scope. That's not showing me anything. The left mixed output is 107B, so that's this one over here, and that would be pin 7, and we got nothing. How does it get there? 15K. So we got counterclockwise and clockwise. The bass, it's in the center. Mid-range is in the center. Bandwidth is all in the center. So that comes down through there, goes up, goes back up. Okay, so it's at R163. What would be R163? It would be off of pin 6. So let's check pin 6. Almost nothing. Pin 5. Almost nothing. What the heck? We still got, and pin 7. Whoa. Well, there's pin 7 now. What? What? We got any, suddenly get something coming out? No. So, no, we don't. We still got the same thing coming out here. But if I go to pin, get rid of channel 1 because you can't see channel 2. If I go to pin 5, I got a little square wave. Aha. Pin 6, I got a little square wave. Pin 7, I have output. And it's varying. And the pot's dirty. I'm playing with the mid-range, which should do something for, yeah, because this is a 1,000 hertz tone. All right, so where am I back here? I am on, that's my input. This is my direct output is the next 3, and then what do they call that? Mixed output is on the next 3. All right. So we'll look at it. Here's my input. There's virtually nothing, of course. I mean, it's so there's direct output right there. Other side of direct output and ground. This is mixed output, nothing, nothing, nothing. Take the load off of that and see. What is that? Well, that could be reverb. So turn my input down. How the input was pretty high there. There we go. Okay, so that's known as noise. Okay. I was overdriving the input by a lot, but still, that's output. Why? Well, let's see. Hang on, I got to get some wires here. Okay. So I just hooked up a couple of wires right back here onto the output of this mixed out. And look what we got. I mean, it's, if I play with the output attenuation, which is here, you can see what it does. I mean, it just flat tops it, but I'm feeding it 2 volts. And there's your input. That's flat topping for the input. But what I got, don't pay any attention to those little knots on the, those little things on the top. They're coming out of the generator. If I bring this out, well, it appears to be working. And so's the reverb. The spring part's working anyway. So, attenuation, tuning, kilohertz. So we want, what do we want to do? Tuning in kilohertz. Yeah. It's, that's interesting. It won't do that. We have to go up. Let's go up to 2.5. So if I take my little, who's it here, 2.5. Okay. Drop my input down a little so it's not beating itself to death. Balance it out. Well, it is working. That's interesting. We got to figure out, see what it sounds like. Hold on, I'll get some more wires hooked up here. Okay, well, with the addition of a bunch of different wires, I got something going into it. I'm just playing some free music here so I won't get hit. But this appears to be working. We'll take a listen. That's adding treble reverb. That's bass, and that's none. Let's cut it off about 2. Yep. And back to flat. So yes, that side is working, just like it's supposed to. I wonder if the other side works. Well, means I gotta hook up some wires back here. Hang on again. Okay, I got everything hooked up to the other side now. And we'll give this a shot. So what have I got? Turn it up. Oh. Okay. There's flat. Oh yeah. There's bass. Not too much of that. How about when I tune it? Oh yeah. Right about there. About 2.5 kilohertz. And when we stop it, you'll be able to hear it even better. There it went. Well, it appears this thing's working. Son of a gun. I'm going to replace the caps over here. Go through and get a couple of these other caps and check these big tantalums there in the back here. Just because. And then I'm going to let it run for a while. And then I'll be back and we'll see how it does. We'll be back. Okay, I'm back. I went through and I changed this capacitor over here, checked these, checked all those. Everything is fine. It really looks good. And I thought I'd show you. I'm gonna do a little alignment on this thing according to what it says. Let's get the manual up here. And the manual says that you need a VTVM. I'm going to use a digital voltmeter, more than 10 megohms impedance, low distortion oscillator, got that, and a AC VTVM and harmonic distortion analyzer. In other words, a HP 333A. I don't have a 333, I have a 332, but it will work. You've seen that in other videos. So, it says, these instructions refer to the left channel. Procedure for the right channel is identical, using the right channel trimmers and test pots. So I got it all hooked up. Connect the oscillator to the input back here in the back. Set input attenuator R101 to 0. Got that. Input is the outside knob here. Connect the distortion meter to the junction of R115 and 121, which is TP1, which is right down there. And see, to connect the scope to the output of the distortion meter, I have a scope connected to the output of my distortion meter going into channel 2. And what we got is that right at the moment. And connect the VTVM to read the voltage between ground and the gate of Q103 with the fixed and floating switch to floating. And I have that is connected right there to the gate of Q103 down there. The manual, by the way, shows that transistor in there the other way. It's evidently it's a different FET than what originally came out with this, but it hasn't been changed. So just a change in the manual, and it does tell you that the gate is on one end. In this case, it's on the end, that end, so it's gate source drain. With the oscillator turned off, adjust R181, the offset, which is this one right here, so that the VTVM reads about plus 0.5 volts. And then back R181 off slowly until the VTVM starts to indicate that the voltage is going negative, and then move it just a little bit more counterclockwise and leave it there. So let us get the meter up here. So we're looking at what, about 0.3, 0.29 with the oscillator off. So let's turn the oscillator off. Okay. So the oscillator is now off, and we're still reading about 0.29. And so it says that it wants me to back off until it gets up to about 0.5 plus 0.5. Right there, about 0.5. Okay. And then you want to back it off slowly until the VTVM starts to indicate that the voltage is going negative. So we'll watch it, the VTVM, drag it up here, 0.2. Boy, that is like almost nothing at all. Yeah, well, it's starting to go negative, and then it says back it off just a tiny bit more. So we're going to leave it right there. So it's like plus 0.1. The difference is a hair's breadth. All right. Then it says adjust the input attenuation. Bring up the manual. It says adjust the input attenuation R101 set to 5 volts. To 5. So the input is the outside one. We'll set it to 5. Set the fixed floating to fixed. That is on. Connect the oscilloscope so that the waveform at the junction of 115 and 121 can be observed. All right, so bring up the scope. Turn the 183, which is this one here, fully counterclockwise. It is fully counterclockwise. And briefly apply a 300 hertz tone, so 300 at 0 dBm, so we'll do that. There's my 0 dBm, and lower the oscillator to minus 30, so that's going to be minus 30. I'm going to change my speed here so we can read it. All right. And slowly rotate 183 clockwise until the level at TP1 stops rising. Okay. The level at TP1 stops rising. I bring my voltage down. Oh. Okay, we're going to do it right about there. So that stopped rising. Increase the oscillator output to 0 again. All right. Oscillator's at 0. Ick. Rotate 183 further clockwise until the waveform just starts to clip. Well, that ain't right. Let's try that one again. It's set to 5. Fixed is on fixed. Okay. Set the fixed floating to the fixed. Connect the oscilloscope so that the waveform at the junction of R115, yeah, down there, turn, all right, fully counterclockwise and briefly apply 300. Oh, 300 at 4. Okay. Then take this down to 0.5. Okay, briefly take it down to 0.5, lower it, slowly rotate it clockwise until the level at TP1 stops rising. So what am I looking at here? Well, it distorts badly. I mean, that's all the way off. Interesting. Well, let's that's on the left channel. Let's try this mess on the right channel and see if we got a difference. Hang on. Okay. Sometimes you have to read the manual, not literally. On a distortion analyzer, you have an input and you have an output. Well, if you do that, what the input and the output, like they say to do it, you end up with the distortion minus the noise, or a very small waveform that will reduce down until you just get this little messy looking line. Well, what they're actually asking for here is for you to have the meter, your scope, across your inputs, not the outputs. Evidently the 333 has a different output than mine does. But anyway, if I do this, where I am now just across the outputs themselves, then all this makes more sense. We're doing the right side now. If we look at the meter up here in the corner, also what it says is not, you have to read it carefully and look at it when you're doing it. What it says is with no input, take this down to 0. Okay, with no input, with this thing down and everybody off on the front, you adjust this 181 here, not until it goes negative, but to the point where it looks like it's going to go negative. Okay, so we got 0.52 right now. Right now it's like 0.534. So if I very slowly turn this meter, or this spot, up, it hadn't doing anything, and doing anything, and doing anything, and then all of a sudden it'll start to go negative right there. It's just starting to go negative, and then you back it off just a skosh. That's what they mean when they say to back 181 off slowly until the VTVM starts to indicate that the voltage is going negative, not into negative, just negative, and then move it slightly more counterclockwise than this and leave it there. That's where it's left. All right, now it says to adjust the input to 5. So I adjust the input to 5, and I turn on the fixed, this is the limiting threshold. Turn on the limiting threshold. You see that we went up different voltage, but we want to look at the scope for this one. And I want to briefly apply plus 0 or 0 level. So I'll briefly apply 0 level, and then I'll give it negative 30, and you adjust this one here. See it? You adjust it until it quits rising, and it's very slow to operate, so you got to do this very slowly, down, up, ever so slightly, right there, and then you give it 0 level again, and you adjust it just a little bit more until it starts to clip. Right there. See where it's starting to clip right there? So back that off. Okay. The rest of that crap you see in there is from wires and things all over the place. Don't worry about it. All right. So that one's done with that. So let's try. Oh, wait a minute. And the next step, it says to apply a 5 kilohertz signal at 0 dB. So we'll do this. We'll apply 5. There's 5 kilohertz at 0 dB. Measure the harmonic distortion at the junction of R115 and R121. So now I have to take off my clip leads so I don't have a loading. And now I want to measure the harmonic distortion there. So at this point, now I do put my output of the distortion analyzer into the scope. All right. Adjust R119 distortion null for minimum distortion. The waveform will be somewhat obscured by noise. I don't have a 30 to 1800 hertz bandpass filter, but so we'll try that. All right. So go back to the scope. Give it a little more oomph and a little bit faster so we can see it. All right, and now we want to adjust 118 for minimum distortion, where it happens right about there. Let's make it a little bigger so we can see what we're doing. See how it's getting dirty? That's because the output of the distortion analyzer is subtracting the fundamentals and everything away from it so that you get less signal out of there. If I twist on the knobs here to get it to the best I can, let's see, at 5,000. There's about the best it'll do. Now see what it looks like? It says that it may look pretty crappy. Well, it does. Let us. And now, when I adjust this, I'll get the best I can get. See it there? See it flattening out? And about there. All right, so that's that side. Let's see if the other side does that. Sometimes the manuals have got to be read literally, and sometimes not so much. All right. So I've got the left and the right connected together. Turn this off. Turn this down. We'll do our 5 volts thing on here. Everybody's off. Got my 5 volts. No, I don't. Why do I not? There we go. 0.5, 0.52, 0.53. Okay, there, it's starting to go negative. It's about the same spot as the other one. And then we'll do the game with the meter, wherever it went. Here it is. All right, disconnect it from here, and we'll put it here and here. All right, and I've already forgotten what it said. So we did that part. Turn this on, turn this to 5. And turn this guy until it can be observed and quits rising. Take everybody back to center here. All right. So connect the oscilloscopes to the waveform and turn 183 bias fully counterclockwise. All right. Oh. $300 hertz. Yeah. Okay. All right. What am I doing? Time base. Thank you. All right. Am I doing something wrong here? My input. Oh, that's interesting. I think the clip lead fell off back here. No, it didn't. Okay. Bad connection. All right. Bane of my existence. Okay. So there's its. Briefly give it 2 or 30 dB or 0 dB, and then take it down to 2. Bring it up so I can see it, and then rock this until it quits rising. Oops, I forgot to turn that on. Till it quits rising. Something's wrong here. Hang on. Well, that's interesting. One of my clip leads thingies is busted on one end, and I wasn't getting it, so fun. All right, so basically we're back to where we were, where we take this side, which has been turned all the way down to one side, like it says in the manual there. Give it 2. I got 2 minus or 0 dB, and then take away that 0, or take it down to minus 30, and Go back to the scope and crank this until it quits going up. Which, whoa! Very, very touchy and slow. So right about there. Now take it back to 0 level. Okay, so take it back to 0 level. Okay, bring the scope down so we can see it, and twist it until it just starts to distort. Right there. Okay, so now we're done with that one. Now it wants me to apply a 5. Let's try that one here. 5 kilohertz signal. There it is. There's my 5 kilohertz signal. Measure harmonic distortion at the junction of where we're at here. So, got to hook the distortion analyzer back up. And hook the output of the distortion analyzer to the scope. Okay. And again, tune it in to the best I can get. Let's see. Okay. That's about the best I can get. And I'm going to turn this down. That's about as low as it's going to go. And then adjust this guy over here for the least amount of noise. Yeah. It's really hard to see for you guys, but it's right about there at 5 kilohertz. So both sides are now working the way they're supposed to, and they were out by quite a little bit. I must admit, somebody had lined all of the pots up straight to each other. And I did notice this side is a little different on its output than this side is. And if you look, you'll see that this side has a flat pack, a dual inline package dip chip here, and this one's got a can. So somebody has changed that in the past, but they seem to work. LM 709 CH, and this one a TLO 72. So there is a difference, I guess, between them. But what does the manual say? Let's see. And get this thing down. So we're talking about IC 101 and 102. There's 101, it's a TLO 72 and a 709. Oh, okay, there it is over there. I'm sorry, I was wrong. I'm an idiot. No problem with me admitting it. That was hidden underneath here. All right, so it is the same. Yeah, the TLO 72 is here and here, and the 709s are here and here. So anyway, the whole thing works the way it's supposed to. I changed out that cap. We've done the alignment. I checked it all out, and it is now correct. Even the fixed floating or fixed and floating limiting threshold. That's what we tested before. The only thing I got to do now is the neon bulb is gone. I wonder if I've got one somewhere around here. Somewhere in the back of my mind. Somewhere way in the back of my mind. That's 24 volts. That ain't going to work. Well, I don't know. Where's it come off of? Look at the manual. Yeah, no. Comes right off of one side of the transformer. So, new. I'm going to have to order one. Doggone it. I knew I had something to look like that. Oh well. Changing light bulbs. That's not all that fancy. Anyway. Well, I didn't need that thing anyway. Alright. Hey, there you go, guys. It works. It wasn't much except the alignment and the this little cap over here. And I've never looked inside one of these. You were the first ones with me. Anyhow, hey, thanks for stopping by. Don't forget to mash the like button and comment on this if you want to. This old stuff is kind of fun to keep it going. And I'd love to get the comments. And don't forget, if you want to support me on Patreon, it would be much appreciated. Thank you very much. So, until next time.